Welcome to this 8th video of real numbers of standard 9. In our previous video we have seen what do we mean by surds. Okay, to recall what is a surd? Under the radical sign, when we write any number, say a, it's called radical, and whatever the root we have taken is n. If a is a positive rational number, n is a natural number greater than 1, and if this number is an irrational number, then we call it as a surd. Now we are going to see what is the simplest form of a surd. Now we have learned what is the simple form of rational number also. Suppose any rational number, suppose we get an answer, say 14 upon say 2. We do not write this as answer. What we do, we divide this number as we remove this common factor from this 2. So it is 2 ones are and 2 sevens are. We write it 7 upon 1, that is 7. If it is minus 15 upon say 12, now these both numbers are divisible by 3. So what we do, we divide this by 3. 3 4s are 12 and 3 5s are 15. So minus 5 upon 4. So like this we try to reduce. If it is reducible further, we will reduce it further also. Say for example, if it is 16 upon 24, and if you divide these two numbers by 2, and if you find that 2 8s are 16, 2 12s are 24. Still these two numbers are divisible further, so you have to divide it again. If you are dividing it by 4, then you will get 4 2s are 8 and 4 3s are 12. Now these 2 and 3 are co-primes and it is not divisible further. So we write the rational numbers also in the P upon Q form, where P and Q are co-prime integers. Though we write only integers, they are always we write in form of co-prime integers, and of course Q is not equal to 0. So we have seen this. These are called simple form of the rational number. Like that we can write the surd also in simple form. How? That we are going to see. Okay. For example, if it is say square root of 25, we can write it as 5. We know 25 is the square of 5. Or we can write this first like this. It is square root of 5 square, and whatever 5 square, if it is radical, it's square root equal. Now taking square and its square root is such two operations which nullify each other, and we get the number 5. Means for example, we can understand that it's square root of a square, it is written as a. So if you remember this, if you understand this, this will be easier for you. Okay. But if it is the square root of 50, okay. Now we know that 50 is a not at all perfect square. But can we have factors of 50 such that one of the factor is perfect square and another is not a perfect square? Then we can write this as to it is 25 2s are 50. Now this square root of product of 25 and 2 we can write as a product of square root of 25 into square root of 2. Okay, because we know this is nothing but it's a, so if we try to understand, it is 25 into 2 raised to its square root means 1 upon 2, and we know that this power can be given to both the numbers separately. So it can be written as 25 raised to half and it is 2 raised to half. What does this mean, raised to half 1 upon 2? It means square root. So surely we can write this as square root of 25 and then square root of 2. Instead of going in such a big thing, we have just split this like this. Okay, but this reasoning behind writing this is this reason. Okay, after this, now what is the square root of 25? We know it is 5, and is the square root of 2 if we write like this. So we have written this square root of 50. Okay, so square root of 50 can be written as 5 into square root of 2. Now this is the simplest form of the surd square root of 50. Okay, square root of 50 is also surd. This is also surd, but we can say square root of 50 is a pure surd. Is an example of pure surd, and here 5 times square root of 2 is simplest form. It is the simplest form of square root of 50, and as it is written in the form of product of rational number into irrational number or rational number into surd, it is also called as mixed surd. It is also called as mixed surd. Now here it is not only important that we have taken 5 out of the surd side, but whatever this remaining part 2 which is under the radical side, it is not at all a perfect square, or it has no other factor which is a perfect square. Okay, let's illustrate this with one more example. Okay, if we take suppose square root of 32. Okay, so if you think, say, what are the factors of 32? If I think, so which is 4 8s are 32. Suppose I have written these factors of 4 and 8. Now, as per this, we can say square root of 4 into square root of 8. Now, square root of 4 is 2 and this is square root of 8. Now, is it the complete answer or is it the simplest form of this? For this, we need to check if 8, which is written under radical sign, does it have any factor which can be a complete square? Now, what are the factors of 8? It is 8 1s are 8 or it is 4 2s are 8. So, 8 factors of 8 are either 8 1s are 8 or 4 2s are 8 also. 8 can be right like this also. Where we get again this 4 is a perfect square. So, this is not the simplest form. So, here what you have to do, so this 8 if you factorize at 4 2s are, and this 2 copying as it is square root of 4 into square root of 2. Okay, so this is 2 into the square root of 4 which is 2 into square root of 2. So we get it square root of 4, 2 2s are 4 into square root of 2. Now whichever square root of 2 is remaining, we do not have any factor of 2 which is a perfect square. So this is going to be the simplest form of this square root of 32. But does it require that you have to do like this? No. How can you do this one? So if you want to do this, you can do, suppose you know what are the factors, exact factors. What you can do, you divide this 32 by say 2, because 2 is the units place, you can divide it by 2. Now 2 1s are and 2 6s are 12. You got it 16 to the 32. Now if you are smart enough to understand that 16 is a perfect square, then you can say square root of 32 is equal to under square root is 16 into 2. Okay, so this can be written as square root of 16 into square root of 2, which is 4 root 2. Like that you can get this. So for smaller number you can get like this. But if you are not enough to understand, you know the perfect square, then you can go for the next. Suppose you are going, so 2 8s are, 2 4s are, 2 2s are and 2 1s are. And then you can make the pairs here, and here you can see that 2 is the remaining number. So you will get, you can write this like this also. Now here for smaller numbers surely you understand, but I am just explaining this type, this method where the numbers are bigger enough. So you can write square root of 32 as under square root, this is what, 2 into 2, that is 2 square, 2 into 2, that is 2 square, and 1 time 2. Now whichever has 2 squared, the square root is going to be 2, here it is going to be 2, and this 2 alone we have to put it under square root sign, so you will get it 4 root 2. What I want to explain you that just do not find any factors of the given number that one is perfect and the other is not perfect. If you find like this, you have to go to this number also. If you have another factor which is also a perfect square, you have to find it that. Okay. So in this way we can see what is the simplest form of the given set. Now let's see the question given in practice set 2.3. I take question number 4. I have copied over here. Simplify the following surds or get its simple form. Question number 4. In that number 1, square root of 27. Now how can we get square root of 27 when the numbers are smaller enough? You can understand. It is 9 3s are 27 when 9 is a perfect square. Or you can go by this method, vertical finding factors. 3 9s are, 3 3s are, 3 1s are. So you have got the pair of 3. 3 3s are into 3. Or you can write directly also like this. So square root of 9 you can write directly also 3, and this is 3 root 3. Now from where this 3 has come? This 3 has come from as a square root of 9 and this. So we have skipped this step writing like this. Okay, you can skip this, and this value you can write directly as 3 and this square root of 3. Okay, square root of 50 already have shown, so I will not go it for again. Now the third one we can go the square root of 250. Suppose the factors which comes to your mind, it is say 25 tens are fine. Now you know 25 is a perfect square. Then what are the factors of 10? Factors of 10 are 5 2s are. Now 5 and 2, they are not perfect squares, so we can keep 10 as it is. And then what is the square root of 25? It is 5 and under root 10, we can keep as it is. Now what is the fourth? Fourth is 100 and square root of 112. Okay. Now I do not know in which perfect square it is going to be factor of that. So how can we do? We can write 112 and divide this number by 2 because in the unit space it's 2. We can divide it by 2. So dividing by 2, we will get 2 5s are 10, 1 remain 12. 5 6 are 12. Now this is not a perfect square. So let's go to divide it further. So 2 2s are 4, 1 remain, 2 8s are 16. Is it a perfect square? No. Again divide it by 2. So 2 1s are 2 4s are. Okay, not perfect square. 2 7s are and 7 1s are. So what did we find? We got the pair of 2 2 times and 7 1 time. So this is under square root 112. We can write it as 2 square into this 2 square and 7 alone. And what will be the square root of 2 square? Going to be simple 2, 2 and under root 7. So simplest form of square root of 112 is 4 root 7. Okay. Like that you can solve the fifth sum also under square root 168. Okay. You can find the factors of 168. As this number is also having 8 in the units place, it is divisible by 2. So let's divide it by 2. 2 8s are 16, 2 4s are 8. This is not a perfect square, so keep on dividing. 2 4s are 2 2s are. This is not perfect square. Again dividing it by 2. 2 2s are 4, 2 1s are. Now 21, 3 7s are 7 1s are. Now here how many pairs do we get? We got a pair of 2 2s are. Now all these numbers are single numbers. So how can we write? We cannot make the group of that. So we can write it here 2 square. And what is this product of 2 3s are 6 and 6 7s are 42. We can write it as 42 also. So instead of writing 2 into 3 into 7, we can make it as 42. Now 42 has no such factors which is going to be perfect square. And then you can get this as a 2 under square root of 42. So in this way we have seen what is the simple form of a surd. Now quickly we are going to see how can we classify the given pairs of surd into like surds and unlike surds. So for this what we have to check. Of course, to classify the surds as like and unlike, what do we mean by like surds? Okay, like surds are the surds where the order and the radicand should be same. If order and radicand are same, then it is called a like surd. For example, in algebraic expression, suppose we have certain algebraic expression 3x, 3y, 3z or 4x minus 2y. If we tell you to tell the like algebraic expression, we concentrate on the variable part. X, where do we find one more x? Yes. So pair of like algebraic expressions are 3x and 4x. Correct. Now x is having here one power, here also one power. If we have any another, say 5x square, this will not match in this group because the power of the x is 2. So here as we say it is a like terms, or here 3y and minus y. Second pair we can have the 3y and minus 2y. These are also like terms. So here what we do, we check the variable part along with its power. So like here in reduced form, we need to check the order and radical. Means for example, if we have square root of a, say p times, and square root of a, it is say q times, then these two surds are going to be like surds. Okay. If this square root part is not say, if it is 1 is say, it is square root of a, and if it is say cube root of say a, are not like terms, are unlike terms, surds. Because here the radicands are same, but the order is not same. So in that case, they are unlike surds. Or if we have square root of a, and square root of b, where the order is same but the radicand are not same, even in that case also they are unlike surds. Okay. So with this we will solve question number 3. So for this question number 3, what is the first pair? The first pair is given under square root 52 and the another is 5 times square root of 30. If you see the order, it is 2. If you see the radicand, they are not same. But can we say directly now that they are not like surds? For that, what we have to do, let's check. Do we have factors of 52 where we can get it simplified form? Now 52 is divisible by 2. So 2 2s are 4 and here 2 6 are 12. Now again this is divisible by 2. 2 1s are 2 3s are, and here 13 1s are. So square root of 52 has a pair of 2 into 2, that is pair of 2. So it is going to be 2 square into 30 and that's why it's going to be 2 times square root of 30. Okay. So simplified form of given surd is 2 times square root of 30. And what is the another number? It is 5 times square root of 30. Now you can check that as 2 times square root of 13 and 5 times square root of 13 are like surds. Correct? Because here we find the radicand is same as well as the order is same. Therefore we can say square root of 52 and 5 times square root of 13 are also like surds. Like this we have to write the answer. Means to decide whether the given pairs are like surd or not, we have to check the reduced form of the given surd. And then if we find that the irrational part is exactly same, its radicand as well as its order is same, in that case they are like, otherwise they are unlike. I hope with this explanation now you can solve the remaining sums from this question. Thank you.